Hello everyone. Today we will discuss about another algorithm to find the minimum spanning tree. As I have mentioned in the previous video that we have two algorithms to find out the minimum spanning tree using the Mendelian method. One is Prim's algorithm and the other one is Pascal's algorithm. Pascal's algorithm we have already discussed in the previous video. Today we will be discussing about the Prim's algorithm which is used to find out the minimum spanning tree. So as I told you before, minimum spanning tree is a tree of a graph, it is a subgraph, which includes all the vertices in the graph and the cost of all the edges add together will be the minimum. So that is the minimum spanning tree. This is an example of a graph which is given. And here we will get n number of spanning trees. So the cost of one of the spanning tree which is mentioned here, that is in the bold line as 58. And this is another example of a minimum spanning tree which is having the cost 37. The bold lines represents the edges in the spanning tree. So these are two spanning trees which is having the cost different, and like this we will find out n number of spanning trees from the given graph, and we will find out what is the cost of each spanning tree, and whichever is having the minimum cost will be the minimum spanning tree. So there are two algorithms, Prim's algorithm and Pascal's algorithm. Pascal's algorithm we have already mentioned before, and today we will be discussing about the Prim's algorithm. So the Prim's algorithm, these are the three steps which we are following. What is included in these three steps is, first we will find out the value yes. Yes is the vertices which is visited, and uh, we are selecting the any element, we can select any vertex or any element, that is R. R will be added to this, and we will be finding the lightest edge such that one endpoint is in S and the other end is in B minus S. A B minus S is nothing but the vertices which are unvisited, and this edge will be added to the A. So A contains the minimum cost edges, and this process will be continuing till B minus S becomes none or becomes 5. These are the steps which is following. We will get an idea of this when we are following the different examples. So we will find out one example first. We will try to solve it by using this technique. So this is a graph. This is a connected graph which is given. A, B, C, D, E, F, and G are the vertices, and the edges are associated with the weight. So weight or the cost which is associated with this, and we have to find out the minimum spanning tree. So the first step is step 0. S is equal to A. That means I am starting with the starting vertex or the root vertex A. So A is added to this. B minus S means the set of vertices which is unvisited. That is, all the other vertices other than A will be included in B minus S. So you will get B, C, D, E, F, and G. And here we will get from A which are the edges outgoing or the edges associated with A which is having the least weight. So here there are two edges, that is 4 and 8, which is the least edge 4. So 4 is the lightest edge in this. So that will be added to the lightest edge set. Now in this, so AB is added to that lightest edge. So AB is included in the minimum spanning tree. That means now B is visited. So B is entered into the set vertices, that is visited vertices, and the remaining vertices are C, D, E, and F, G. Now we will check one lightest edge. How we will calculate? One vertex should be in S and the remaining unvisited vertices. So A is having the vertex, having the edge which is left is A, C, and from B the lightest edge is 9 is there, 8 is there, and 10. So we will type 8. So both are having same values, A, C, and B, D, C. That's what it is included here. A, C, and B, D is having the same weight, which is the least cost. So that will be added, and any of the vertex you can visit here. So I am visiting here the edge BD. So ABD is visited. ABD is visited. And which is the remaining edge is CEFG. Now we will check which is having the least edge, which is included, which is starting from A, B, and D. So A is 8, B is 9, 8 is already added, so B is 9, and D is what? 2. So without any doubt we can say the cost, the least cost is D, C. So that is the lightest edge. So next we will visit C. So after that we got here C. So A, B, C, D will be there in the set S, and B minus S is E, F and G. Now we will check again, the same process will be continued. That means we will check from A, B, C, D, which is the least edge. So from A is 8, from B is 9, from D is 9, and from C is 1. So without any cause we will, without any doubt we will add CF, which is having the first 1. So lightest edge is CF. Next we will let's visit EF. Now we are visiting F. That means this edge will be CF will be added here, and A, B, C, D, F are the visited edges, and the remaining vertices is E and G. So from E and G we will check from A, B, C, D, F to E and G, which is a minimum cost. So from A it is 8, from B it is 9, from C no vertices, from D it's 9, and from F it is 2. So without any question, G is not added, right? So without any doubt, we will add FG to the list, and G will be the vertex which will be visited. So FG is the lightest edge, and we will visit G. So this is the process. So G is visited and FG is added. Now which is the only unvisited vertex is what? E. So we will check the same process, we will continue and we will check. From A, the least edge is 8. From B, the least edge is 9. From C, no vertex, no edges. From D, it's 7 and 9 is there. So 7 we will take. From F, it is 5. From G, it is 6. So which is having the least value. Without any doubt, we can say that EF is having the least value in this. So EF will be added to the lightest edge. And after adding EF, we will get E also will be visited. So EF is added. So B minus S becomes what? Null value. That means we have visited all the vertices A, B, C, D, E and F, E, F and G. And now we got the complete MST by all the vertices are visited, and which are the edges include A, B, B, D, C, D, C, F, F, G and F, E. So after adding the full values, what is the value we will be getting? What is the minimum cost of this minimum spanning tree which was we have found here? It is 4 plus 8 plus 2 plus 1 plus 5 plus 2. What is the answer? That will be the cost of this minimum spanning tree. So this is the easiest method of finding the minimum spanning tree. And so we have studied two algorithms to find the minimum spanning tree. One is Pascal's algorithm and the other one is Crum's algorithm. Pascal's algorithm is by using, at a time we will be selecting the least edge, and we will check whether after adding that edge we will get a cycle or not. If it is not, if you are not getting cycle, that edge will be included, otherwise it will be discarded. Here we are using another approach. We will be checking each edge at a time on the vertex and visited vertices, and we will be finding out the minimum spanning tree by taking every aspect of the edges. So hope you understood the Prim's algorithm to find the minimum spanning tree. We will be seeing you on the next video. Thank you.